In macroeconomics, one diagram captures the essence of John Maynard Keynes's contribution more cleanly than any other. It is called the Keynesian Cross. Two lines on a graph, an angle, a point of equilibrium. From that simple picture comes the entire modern theory of how government spending stabilizes an economy, how a deflationary gap forms, and why fiscal expansion can be the medicine that pulls an economy back to full employment. In this video, we walk through that diagram, build it from first principles, and use it to understand the fiscal multiplier, the deflationary gap, and the balanced budget multiplier, including the elegant Haavelmo theorem that surprises every student who meets it for the first time. Let's start with the basic structure. In a closed economy with no foreign trade, aggregate demand, total spending, has three components. Consumption by households, which we call C, investment by firms, which we call I, and government spending, which we call G. The sum is called aggregate expenditure, written AE. So AE equals C plus I plus G. This is the demand side of the economy. Now we need a theory of how each component is determined. Investment, for now, we will treat as fixed, a number determined by business confidence, interest rates, and expectations. Call it I bar. Government spending is set by policy, chosen by Parliament or Congress. Call it G bar. The interesting variable is consumption, because consumption depends on income. Keynes's central insight was this: when households earn more income, they spend more, but they don't spend all of it. They save some. The fraction of each new dollar of income that is consumed is called the marginal propensity to consume, written as MPC, or sometimes the lowercase letter c. Typically, MPC is somewhere between 0.6 and 0.9, say 0.8 in a typical advanced economy. The complementary fraction is the marginal propensity to save, written as the lowercase letter s, which equals 1 minus MPC. So the consumption function looks like this. Consumption equals autonomous consumption, the part that doesn't depend on income, plus MPC times income. In symbols, C equals C0 plus C1 times Y. The slope of this line is the MPC. The intercept is autonomous consumption. Now we can write the full aggregate expenditure function. AE equals C plus I plus G, substituting AE equals C0 plus C1 times Y, plus I bar, plus G bar. Grouping autonomous terms, AE equals a plus C1 times Y, where A is the sum of all autonomous components, autonomous consumption, investment, and government spending. This is a straight line with slope C1, the MPC. Now we add the second line, the 45-degree line. The 45-degree line is the locus of points where actual output equals aggregate expenditure. Y equals AE. This is the equilibrium condition. In equilibrium, what households, firms, and government spend must equal what the economy produces. If spending exceeds output, inventories drain and firms ramp up production. If spending falls below output, inventories pile up and firms cut back. Only at the point where Y equals AE is the system in balance. The Keynesian cross is simply these two lines drawn together on a graph with output on the horizontal axis and aggregate expenditure on the vertical axis. The 45-degree line shows all possible equilibria. The AE line shows actual planned spending at each level of income. They intersect at exactly one point, the equilibrium output, which we call Y star. The mathematics gives us a clean formula. At equilibrium, Y equals AE. So Y equals a plus C1 times Y. Rearranging, Y minus C1 Y equals A. So Y times 1 minus C1 equals A. And finally, Y star equals a divided by 1 minus C1. That fraction, 1 over 1 minus C1, is the multiplier, sometimes called the Keynesian multiplier or the autonomous expenditure multiplier. If MPC is 0.8, the multiplier is 1 over 0.2, which is 5. That means an extra $1 of autonomous spending from any source generates $5 of equilibrium output. This is the famous multiplier effect. The first dollar becomes income for someone. That person spends 80 cents, which becomes income for the next person who spends 64 cents. Round after round, the spending propagates. The total impact is 5 times the initial impulse. Now let's introduce the deflationary gap, Suppose the economy has a level of output associated with full employment. Call it Y sub F. Every worker who wants a job has one. Every factory is operating at normal capacity. At Y sub F, the economy is producing as much as it can without setting off inflationary pressures. But there is no guarantee that the equilibrium Y star equals the full employment level Y sub F. In Keynes's analysis, this was the central problem of the 1930s. The economy could find equilibrium below full employment. Households could be too pessimistic. Investment could be too low. Government spending could be inadequate. The aggregate expenditure line could intersect the 45-degree line at a point well to the left of Y sub F. When that happens, we have a deflationary gap. The economy is in equilibrium, but it is an underemployment equilibrium. Workers are jobless. Factories are idle. Output is below potential. And there is no automatic market force that will close the gap. Classical economics, before Keynes, assumed the gap would close on its own. Wages would fall. Prices would adjust, the market would clear. Keynes argued that in the short run, this process did not work. Wages were sticky, prices were sticky. The economy could stay in the underemployment equilibrium for years, even decades. So how do we close the gap? Here is where fiscal policy enters. If the government increases its spending by a certain amount, let's call it delta G, then aggregate expenditure shifts up by delta G. The AE line moves up vertically. The new intersection with the 45-degree line is to the right of the old one. Equilibrium output rises. With the right amount of delta G, output can be brought all the way to the full employment level Y sub F. The deflationary gap is closed. But the beautiful part is that the government doesn't need to spend delta G equal to the gap. Because of the multiplier, a smaller increase in G generates a larger increase in Y. If the multiplier is 5, then a $1 billion increase in government spending generates a $5 billion increase in equilibrium output. So to close a $5 billion gap, the government only needs to spend $1 billion. This is fiscal policy at maximum leverage. But spending requires financing. The government has two options: issue bonds, borrow the money, or raise taxes. Each method has a different effect on the multiplier. Bond financing is the classic Keynesian approach. The government issues new debt to fund the spending. Households or banks buy the bonds. The government then spends the proceeds. The full multiplier kicks in. A $1 billion bond finance spending program raises equilibrium output by 1 over 1 minus C1, which is 5 billion if MPC is 0.8. The economy expands by the full multiplied amount. Tax financing is different. If the government raises taxes by delta T to fund a delta G of equal size, the taxpayers now have less disposable income. Their consumption falls. By how much? By MPC times delta T. So the consumption function shifts down by C1 times delta T. The aggregate expenditure line shifts down by that amount, even before we add the new G. Net of all effects, the AE line shifts up by delta G minus C1 times delta T. With delta G equal to delta T, that net shift is delta G times 1 minus C1. The new equilibrium output is the old plus delta G times 1 minus C1, multiplied by the multiplier of 1 over 1 minus C1. The two terms cancel beautifully, leaving exactly delta G. This is the Haavelmo theorem. The balanced budget multiplier equals 1. A balanced increase in spending and taxes, where the government raises taxes by the same amount it increases spending, generates an increase in equilibrium output exactly equal to the spending itself. The multiplier is 1, not 5. But it is positive, it still expands output. And it does so without adding to the national debt. So the contrast is clear. Bond-financed expansion has a multiplier of 1 over 1 minus C1, for example, 5. Tax-financed expansion at the same scale has a multiplier of 1. The bond-financed option is more powerful per dollar of spending, but it accumulates public debt. The tax-financed option is weaker but fiscally neutral. The choice between them depends on whether the priority is maximum stimulation or minimum debt accumulation. Both close the deflationary gap, just by different amounts and at different fiscal costs. There is one more elegant point. In the balanced budget case, Even though households pay more taxes, equilibrium output rises. Why? Because the government spends every dollar it collects, but households would only have spent MPC times each dollar they keep. The government is, in effect, a higher spender than the average household. The dollar that moves from the household to the government and back to the economy as G is more activist than the dollar that would have stayed with the household and been partly saved. This is the deep economic intuition behind why even a balanced budget expansion stimulates output. The Keynesian cross is one of the most useful diagrams in macroeconomics. It shows, in two intersecting lines, why government spending matters, why the multiplier exists, why deflationary gaps form, why fiscal policy can fix them, and why bond financing is more powerful per dollar than tax financing, but at the cost of higher debt. Every modern fiscal policy debate, from Depression-era public works to pandemic stimulus checks, ultimately rests on this analysis. There are extensions, of course. In an open economy, some spending leaks abroad as imports, reducing the multiplier. In an economy with taxes that depend on income, the multiplier shrinks further. In an economy at full employment, additional fiscal expansion produces inflation rather than output. The Keynesian cross is a starting point, not a complete theory. But as a starting point, it is unmatched in clarity. Two lines, one intersection, the whole logic of fiscal policy in a single picture. If this kind of clean macroeconomic storytelling helps you understand how economies actually work, please share this video with someone who would benefit from it. And subscribe to Macroeconomics with Michael for more deep dives into the foundational ideas that shape modern fiscal policy.